Hi there, in this video we're going to be finding the critical values for the following function. Now, in order to do this, we have to first find the derivative of f of x, and to do that, we need to use the quotient rule, which is the derivative of f multiply g, subtract, then the derivative of g, leave f alone, all over g squared. So, f in this particular function's case is going to be x plus 1. The derivative of x plus 1 is just going to be just a 1. So 1, then we leave g alone, g is the bottom, so it's going to be x squared minus x, then subtract, notice then the derivative of the bottom, that is going to be a 2x minus 1, and then we leave f alone, so there's going to be an x plus 1 over here, and then all of this is going to be under, or over rather, g squared, so we have x squared minus x, all of this squared. And now we just have to simplify this. So working from the left-hand side, we're going to have an x, we're going to have a x squared minus x, and then negative, and we put this over there, it's going to be a negative 2x squared, so negative 2x squared. And then it's going to be a negative 2x, so negative 2x. And then we have it'll be positive x here, then just a positive 1. Now combining like terms, we're going to be having a negative x out here, negative x squared. These two terms here, this positive x and negative x, cancel out, so we can ignore those. We took care of these ones here. And we have negative 2x, and then we have a positive 1. And all of this, mind you, is over x squared minus x squared. Now the next step is to find the critical values, because now this is equal to the derivative of f of x. You find critical values by either where the derivative is undefined or where the derivative is equal to 0. So let's look at the first option, where the derivative is undefined. Where is this function undefined? Well, it's either going to have a 0 as x, if x were equal to 0, the denominator is going to be 0 and thus undefined. So x equaling 0 is a possible option. And let's say x was equal to 1. If x was 1, it would also be 0, so x equaling 1. That's pretty much the only x values that will make this denominator equal to 0. Now normally we would say these are the critical values, but they're not, and they're not for the reason that they're not defined within the original function. In order for these to be the critical values, they need to be undefined in the derivative, but defined inside the original function. Because if we were to put a 0 over here, we would have this would be undefined. Similarly with the 1, and as such, none of these values here are actually critical values. The 0 and 1, we can't use them, which means we can't use option 1. And what we have to do instead is set this function here equal to 0 and solve for x. So let me just make some room here. So to do this, we're going to be using the quadratic formula. And to do that, we have to recognize that this function here, when you're trying to solve for x to be equal to 0, it's equivalent to just using the numerator. So we can just have equal to negative x squared, negative 2x, then positive 1. And the quadratic formula is negative b plus or minus square root 4, or rather b squared negative 4ac over b squared, or rather I believe it's 2a. So plugging those values in then we have, and that's going to be the numerator, it's all going to be under 2a, a is going to be negative 1. And now simplifying this a bit, we're going to be having a positive 2 plus or minus, and what's inside here? Well, we can see this is going to be a positive 4, then that's going to be just a 1, so it's just going to be positive 4 there. This one's going to be a positive 4 as well, so that's going to give me an 8, so it's all going to be plus or minus 8 over, then this one would be negative 2. And we can see here finally that this is going to be the critical point. This is where the derivative is going to be equal to 0. It's going to be 2 plus or minus the square root of 8 over negative 2. Thank you for watching this video. If you have any questions, feel free to ask in the comment section below or PM me. And I do hope you're having a fantastic day.